Again, we're in chapter 6, section 6. This is part 2, dealing with Mersenne numbers. So Mersenne, who was a French monk, was interested in prime numbers of the form 2 to the n minus 1. So 2 to the n minus 1, where n is a prime number. Okay, so again, prime numbers coming up here. So today, numbers known that take the form of 2 to the n minus 1 are known as Mersenne numbers. Okay, some Mersenne numbers are prime and some are composite. And remember, composite means not prime. We learned that in lesson 6.5. Okay, so again, some are prime, some are composite. So 2 to the 2 minus 1 and 2 to the 3 minus 1 are prime, but the number 2 to the 11 minus 1 equals 2047 is not prime, because 2047 is 23 times 89. Okay, so now we're going to decide whether 2 to the 5th minus 1 is a prime number. Okay, so first thing we have to do is we have to figure out 2 to the 5th. Okay, so when you count them on your fingers, okay, 2 to the 5th, remember we evaluate as 2 times 2 times 2 times 2 times 2. Okay, so it means we have 5 2's. Okay, so 2, when we do this, we do 2 and then we just deal with 2 at a time. So we get 32. Okay, so now our Mersenne prime then would be 2 to the 5th minus 1, which we said was 32 minus 1. So we're looking at 31. Remember last time we talked about how to check to see if there's any factors of a number. We did that by taking our 31, right, or whatever other number we're doing, and we take the square root of that, and then we go up to the square root. Okay, now 31, square root of 31, is going to be somewhere about 5.5, because 25 is a perfect square. So the square root of 25 is 5. Okay, so again, we know this because the square root of 25 is 5. And the square root of 36 is 6. Okay, so this falls between those, so we know it's got to be between 5 and 6. So we only have to check the numbers up to 5, because if we can't find a number up to 5, then we're not going to find the prime. So we know 1 works, 1 and 31. Okay, it's not even, so 2's out. When we check 3, we add the digits together. 3 plus 1 gives us 4, so 3's out. 4 won't work, because 2 didn't work, and it's not even, so anything even won't work. And then we try 5. Remember, if it's 5, it has to end in 5 or 0, so 5's out. So that means this is prime, because these are our only factors. So only factors are 1 and itself, therefore prime. So 2 to the 5th minus 1 is a prime number, and then again, because it has that format, this would be a Mersenne prime. So our final answer would be 31 is a Mersenne prime. Okay, I'm writing on the notes that I made for you, and I apologize, I did not realize that the space was so tight. I will fix it for next year. Okay, so now we're going to take a look at another way to try to generate prime numbers. Generating primes is a very powerful tool in number theory and in computer science, because it helps us encrypt things. The bigger the number we have, the harder it is to figure out if it's a factor or a prime, because the more numbers that we'd have to choose. Okay, so that's the big idea there. That's why we care about this stuff and why it's important. Very, very useful in computer sciences and higher number math theory.